So here we are in 2022. When I was young, they used to make disaster movies that were totally unbelievable, but I'm beginning to think I'm an extra in one now, with this COVID and then the other thing, and oh God, every time I watch the television or listen to the radio, it's depressing. So working on the 1914 Hall-Scott engine is a very nice light relief, I must say.
Yeah, so what we're trying to do is get what they, in the modern day terms, called a valve collet off. But it's slightly different setup to a modern setup. Yeah, just in case that was the... It's all about when you're flying through the air in an aeroplane, nothing can just fall off and disappear. I've spent many years in the air.
See, it's got these little split pins, so that if the valve was to break or something, or say this lot up here was to give trouble, the valve wouldn't drop into the cylinder. I mean, I can't imagine. But it's got quite a lot of slack in the valve guide, so we think we might do something about that.
Yeah, you can see that, can't you?
Yeah. We had some valve guides made, and after we had the valve guides made, the seats were miles out, so we had to make this tool up, you know. This is a shed tool, this is, and it's got a cutter there, and we turn it, and obviously it cuts the valve seat, but it's all right, but we're not knocked out of it. So now what we're going to do, we're going to put it in a grinder that does the valve seats, yeah, grinds the valve seats. Grind that to dead at 45 degrees that the valve seats will be at. So in other words, it might be just a little bit more accurate. So we'll see. We think we're going to do the valve guides ourselves now because we got somebody to do it. And it was all right, but we're not convinced that they got the angles spot on. So we're going to try doing it ourselves, and we do it with a material called coal phos, which I keep in my Alzheimer's drawer. Absolute fortune. And I probably lost it.
Did we use it?
No, I don't think we used it. I think that might be something to do with it. Oh, there it is.
You heat it up, you can watch the oil bubbling out a bit.
Yeah.
It makes it perfect for valve guides. It's like a bronze.
Yeah.
I think they call it coal phos 90, don't they?
Something like that, yeah.
Oil light is the other term. So you could even make a tool that comes off of these. Goes like that. Goes onto the mill.
Yeah, yeah.
Again, dangling it off the side, but
Yeah, but if we came off of them with a piece of angle, we could grind it all up and make it square. It's not something that we would take lightly.
no, we've got to really sort of
really
look
think
at
about
it,
it.
set it up,
Yeah, 'cause
decide whether we can do it.
once we've messed it up, we're in trouble.
Yeah, that's it. We've got to know exactly how we're going to do it and know that it's going to work,
Yeah,
rather than sort of blading in and thinking, oh, that didn't work, what we're going to do now.
yeah, exactly.
Well, imagine a great big valve coming wobbling its way up the guide. By the time it's found the seat, it's too late. It needs to go again.
Considering there's no positive oil into the valve guides, and they're 100 years old, right, so they're a bit wobbly. So So it's our intention to fit this on our milling machine with a fixture, set the boring head at an angle and go through there with a 1/2 inch reamer. But we want to make sure that we keep it exactly as it should be, so we don't move the seats inside. And then, when we've done that, we're going to turn some more of these up, this very special metal called Colbros, and that's going to get put in there, and then we'll obviously ream it out to size to suit the valve, and that will overcome the loose valve guides. We've refaced the base of the valve, because there wasn't a lot of wear on them really, they were in very good condition. So that's going to be, and then hopefully we'll have a really good seal on the engine. But this is amazing, because this is obviously a casting, and it's machined there, and then all the way up to the cylinder head there, and then 2 flats machined on there. And to be honest, it's amazing. You know, I mean, when you think it's 1914, I think they made the first one, you can tell how thin it is. And of course the other thing with the cylinder head is that the water gallery is joined here, so we make up a thing to go on there, but we'll show you that when we do it, because it's quite clever really. But you can use the cylinder head that way or that way, because it's exactly symmetrical. So the exhaust ports is the same size as the inlet ports, which is not particularly clever because the gas speed is very slow, and it could do it to make it more of a car engine, you know, with like progression and what have you. Not having bloody great ports that you can nearly get your hand in would be better, but obviously we can't do anything about that. But you know, again, you know, I mean, Americans certainly knew what they were doing. That is a lovely, lovely job. That's a beautiful casting. It's machined all over to get it down to weight. It rests on that lip there. Now that tends to leak there, so we're going to try and think of some scheme there, because there's no point in putting a gasket in there because it just beats the gasket out of the way. So I don't know what we're going to do there, but it might result to tiger seal again. And there we are. 4 plugs, so we can put a plug in there and we can put a plug in there. Now previously we had both of them on the exhaust side, but the next time we put it together I'm going to change the plug leads, and I'm going to have one on the exhaust side and one on the inlet side, opposing one another. So that'll see how that goes. And then obviously what happens is you have the stud goes down, and it goes right down through the crankcase, through the main bearings, and holds the main bearings. And like the BMC engine, what's it called, the CVH engine, and obviously the stud goes into that slot there, and the other barrel's just there. Nut tightens down, and you've got this long stud, which is obviously made of some bloody good metal, but quite, you know, fabulous design really, because obviously they'd have to make the crankcase much heavier than they have to make it, having these studs going right through to the main bearings. So, you know, a lot of good thought and lovely bits of engineering. You know, I think it's you know, considering it's 100 years old, this engine, I think it's a knockout. What it is, well, obviously we've got to machine those things at a dead right angle. You can't afford to do it wrong, because then it won't match up with the seats on the inside for the valve. We don't want to start a load of machining being in a shed. So what we're going to do, we're going to make a fixture to fit it on the machine, and we started to make the fixture, and it's turned out a very nice job, but it don't work. So now we're looking at it, whereas at one stage we were going to bolt this to the thing and come in at an angle, the milling machine, it doesn't work. So what we're talking about now is possibly putting that on the milling machine, bolting that all down like that, and then laying the head down so we can come in like that. So that's the next step. But you know, we made this thinking we'd be able to use it flat on the bed, but we can't. Very often with these things, you have to make the thing before you can tell it's not going to work. But luckily we've got this very nice angle plate, which came from my old mate Bob, who unfortunately has got Alzheimer's and is in a home now. He actually went to school, the same school as me. We cleared his workshop out, and this was one of the bits we bought off them. Well, my son cleared the workshop out and I bought this off my son. Typical Bob, it's a good bit of kit because old Bob knew his job. He was an instrument maker. And if I ever had any real big problems, I always knew it in the background I could go and see Bob. Unfortunately, I can't now. But I wasn't the only one neither, because you go to Bob's and there'd be bits of Porsche and bits of Lotus and all sorts of stuff. He was always working on loads of stuff for car dealers and people up in London, and you know, I don't know what they're all doing now. They must just have everybody stop work. Well, I don't think there's anybody would have took the place of Bob in his little shed.
You can go down to follow the guide. All we got to do is make sure we set that up properly. But that's really good news. So obviously I'm just looking at the moment, but what we've got to try and do is get that, so I don't know, go in there, lovely. Yeah, you can see that this, if you sort of like look at that gap there, you can see it's slightly wrong possibly.
Not a million miles away though.
No, I'd say that that's 15 degrees that angle. Yeah, so we'll bore this hole out bigger, we'll ream it out, drill it and then ream it. Then we'll make a new guide out of coal phos or oil light, I think same thing. Then we'll heat it up to shrink it in there and then ream it out to the original size. You drill it, it really drills and it almost drills under. All it was, but it's not. We're going to do it halfway, measure it, and then just measure it. It might be a bit much.
So it's nice to put a drill down it anyway.
Yeah. Let's see, 12 mil. If we drill it to 1.5 inch drill, which is 21/64,
Yeah.
that's about 12, just over 12.
See, it's only just cleaning up. Quite a lot of wear that side.
You can see there's more meat that way than there is that way.
You can see how old mate got his knickers in a twist.
Oh yeah.
There than it is there.
Yeah. See, if that was a end mill, it would go in and do that, but all that's doing, that's just following the hole
Oh yes,
to
it
a certain
was.
extent.
Yeah. Yeah. Well, I think we ought to try one.
See how we get
I
on.
think we can always turn our up and get ourselves up to the top.
There's the seat there. Yeah, I think there's a little lip. Yeah, look, there's a little lip on it.
As you see, when that rocker rocks on it, it rocks it sideways.
Yeah.
Can't be tappy bucket. aeroplane engine, and I've been driving it on the road and all sorts of things. It's probably done more hours than any aeroplane engine's ever done of that type.
You can see in there. You can hear it cutting one side. Just takes the shine off the board.
Yeah.
And when you put the rings in, it's sort of like you can really feel them scraping, you know.
But one of the little things that happen, these rockers, obviously, when they're on the engine, oh, they press on there to open the valve. And they're lovely, look, I mean, you know, 1917, look, roller rockers, lovely. That shiny bit is where the felt goes to cause the oil seal. But anyway, what was happening, if you look at it, you can see there's a little tiny mark there. And that was hitting on there. So when I took it to bits, old John said about it, and I knew about it, but, you know, so John said, why don't we make a little washer up to go in there, give it a little bit more spring pressure, which won't do any harm, and then obviously it leaves a bigger gap there. Because one of the reasons the valve guides were probably worn could easily be that was pushing that sideways. So anyway, that little washer's cured that. So I think that would be a bit of an improvement. So, ever since I've had this car, I've never really been knocked out with the engine. You know, it's all right, but it's never wonderful. Because when we took it to bits the first time, we never mixed any of these shims up. You know, we were very careful to never mix them up. We put them all back, and we built the engine up, and the engine was good, and the crank turned quite nicely, but it wasn't really like you couldn't spin it, which is what I like. But there's a lot of ifs and ands. We made this oil seal set up on here so that we could fit the flywheel instead of obviously a propeller, because normally this comes out here and the propeller fits there. So we made this bit and we shrunk it on, and then we used a nut that originally held the thrust on, and we made our own thrust, which is this thing here. And luckily, underneath that rear main, there was this thickness of shims. So we measured that exactly, we measured the shims exactly, and we made that exactly the same size as the shims. And then that bearing takes the thrust, whereas originally it had a bearing in there that took the thrust. But it meant that we could get the flywheel close up to the engine, which is what we wanted to do. And then that bit there had an oil seal. Well, we couldn't do that because we didn't have room, so we did this setup. And we were a bit concerned that it wouldn't stop the oil running out. It worked like a charm. Nothing ever came out of the rear main, so we were very clever there, and we were, you know, pleased with that. And then we managed to put a bush in there for the first motion shaft of the, well, actually it's not of the gearbox, it's of the clutch shaft. So that all worked out good. But anyway, yesterday we put the crank in, and although it was all right, it wasn't perfection, so we've now decided we're going to go for perfection. We're going to get that crank to spin in there, because all the original white metal's in very good condition, and we don't really want to hurt it. We don't really want to have it all line-born and everything, because it's unnecessary. So we're going to make a big effort. So we just measured all the shims, the thickness of them, and we found that one of them, this one in particular, has got a different thickness this side to this side. So we're now going to equalise that. So at least that's it. And then we're going to put the crank in one more time and see how we get on. We're going to torque the main down. You know, we're going to make every effort try and find out why we can't spin the crank. Because it could be that the crank's bent, but I don't think it is. So we're going for perfection. So this could take all day to do this, but we'll see. As we put the crank, John put the crank in yesterday and it was quite good, you know. It's like, well, what do you think? Oh, it's the oil dragging and all that. But, you know, and when we put engines together, you can put the crank in and you can go like that and they spin. And that's how this wants to be, I reckon. So we're going to try that. So this video could finish up being quite a saga. But anyway, it might be interesting and we're probably going to learn something ourselves. So we'll see how we get on. We also noticed that the oil seal had touched there. Now that could be that when you rev it, there's a little bit of a thing because the clearance, we made that really close there. So we scraped the high spots off. So that could be another reason the crank's tight, but I don't think it is. I think it only touches there when you're revving it and, you know, the flywheel gets a bit of a wobble or whatever.
See, this has got the shims burred over on it. See down here where the shims touch on the crank.
Yeah. What we'll have to do is really try and look at that.
You see, look there. Look, you can see one's burred over.
Yeah, they're shiny. I see them.
So look.
That's so that we don't have one shim sticking out a little bit. This old scraper, I found it literally in a load of old tools and I cleaned it up and I put a new handle on it because it didn't have a handle. But it's an old thing and it's called a footprint. And there's the thing, look, footprint. So that's a bit of real old bloody, you know, I mean that could be 100 years old, that scraper. Certainly as old as me, that's for sure. Which is getting on for 100 years old, I might say. Originally, there was a great big thrust race in there because obviously with a propeller on it, I mean an aeroplane can hang on its propeller, so the thrust race was very, very important. So it was a bloody great thing. And then obviously this came out here and the propeller fitted on there. But what we wanted to do, we wanted to get it flywheel, which is a bloody great lump, right up against there. So we took that thrust race out, and luckily those shims was about the same thickness as that, or exactly actually an 1/8 of an inch, which is an English measurement, which obviously the Americans go by. So what we did was we made this sort of cage bearing up here, and then bolted that underneath there. And then we made this great lump of metal up here, which we heated up hot and shrunk onto the crank because it's actually got a keyway. And then we made this big nut because originally there was a nut on there that squeezed up the original thrust race. So we made this big nut up and we screwed that on like a loony. You can see where we heated it up, dropped it on, tightened that up, and then we put a little bit of MIG weld just there, because we thought, well, if we ever have to get it off, we could grind that away, and we certainly don't want that to come loose, so we MIG welded it, which is a bit raunchy, but, you know, it works. But we were concerned that this oil seal wouldn't work, because originally it had a proper oil seal there. So what we did was we plugged up the bolts that originally held the oil seal on, and then we just made that a very close fit to there. And we put this very coarse thread so that when the crank's going it winds the oil back. And as it happened it turned out to be a great success because it totally leak at all. But then again we did convert this engine to dry sump, which means in theory there shouldn't be any oil in there because it should be sucked out by the dry sump system. But anyway, it was a great success. And the reason we made it dry sump was because the sump was very deep and we put it in a car, it'd almost be dragging on the ground. So, and of course the original Peugeot, which was what we were making a replica of, was dry sumped, and the tank where we put it is exactly where it was on the original car. So it's another little bit of, you know, makes the car somewhere near what it should be. But getting this to spin is going to be the challenge of the day. The castellation gets bent over, doesn't it?
Yeah.
So that's how it wants to be. Right, get hold of it like that and go like that. If we can achieve that, I'll be knocked out. What happens is those shims are very close to the crank, and what John's theory is that when you tighten it down, they push sideways like that and push on the crank. And actually, when you look at them, some of them were actually shiny. So John's just took a few thou off each one. So what I'm doing is I'm putting this razor blade in there, making sure that there's clearance like that, and then lifting it out, and the same thing there, and pushing them down, then carefully putting the cap on. Well, we'd be on the floor now, wouldn't we?
Oh
We
yeah.
wouldn't have an engine stand, we'd be on the floor.
Yeah.
Well, that's a pretty good start.
That's 1000% on yesterday, isn't it?
Yes,
That's how it wants to be. Look, no sticking at all.
1000%. What's that? That's it, isn't it? I'd say.
55. 55.
Yeah. Lose it off and go back to 55.
Yeah?
Yeah. Well, I think that's a success story.
Oh yeah.
You put the flywheel on that, that'll spin for half an hour, I reckon.
Well, 514s
Fit.
are 50, 70 pounds.
Now look,
40 kg.
and then
80.
that is another 3. So it's 43 kilograms or 6.5 stone, isn't it? So that's 43 kilograms or 6.5 stone, which is going to hang on there. So you can see how we had to make that a very secure job. I must say, you know, we ain't designers and we ain't mathematicians, so we thought, well, we just go over the top and make it as strong as possible. And as it happens, it's worked. But in the end, we used the Mercedes bolts to do it up, because this comes off of a Mercedes van, which had done 100,000 miles or more before we actually took it out. We had it years ago, we bought it 40 years ago when we used to take the Bugattis about. But anyway, we assembled it all with Bugatti bits, but I took it somewhere and was driving it and I thought, well, that doesn't sound right, and I stopped and the flywheel was loose. So we had to put 2 dowels in it. So ever since we put the dowels in, it's not leaked. So the next thing with the clutch was, if you really gunned it, you could make the clutch slip. So again, you know, we thought, what's the easy way out? So we got onto a firm in America and they supplied us with these sintered clutch segments. So we used the original clutch and we just took the linings off and we riveted these, you know, they supplied them with the rivets and everything. And so we put these sintered bits on the original clutch plate and they worked like a charm. So another bit of luck we had. And then we obviously had to have the shaft that goes in there And the first time we did it, we sort of bodged up an original old clutch, and we welded it together, and you know, it wasn't particularly beautiful, but it worked and it got us going. And then the second time we took it to bits, we machined it from the solid and made a real proper job of it. But before we put it in the car, we'll look at that and you can see how we managed to do that. Because we used a little bit of Bentley. Luckily, we knew a little bit about old vintage Bentleys, and we had a few bits kicking about. And so we used a bit of an old Bentley to give a bit of a universal. But anyway, we'll show you that later. Which are always a little bit worrying because they're made of bloody copper, and copper is a dangerous stuff. Because it work hardens and sometimes fractures, but you know, to do anything about that would be a right drama. This is the original oil pump from this engine, right? A 10-litre engine, aeroplane engine, and this has got to be a lesson to us all, really. Look at it, there's nothing of it. And what happened was, that mounted in the sun, like there, and then it had a gear running from that gear there, it had a shaft coming up here like that, driving it. Well, because this was in the bottom of the sun, which is miles down, and of course it's all right, but in that car it has like a subframe, which is how the original car was, and it would have just hit the floor. So we cut the sump off, and we'll show you that. And but that was the original oil pump, and it's said to have had 14 psi, what do they call it, pressure, and it obviously did the job because it didn't go wrong. It was altogether lovely. So obviously when I first got involved in this, I was keeping my eyes open for anything hallscott, and I managed to buy this from a bloke in Canada, and it's like a manual for the hallscott engine. But it's quite funny really, because I had pictures of the Peugeot, which was what we were copying, and the radiator, we only had a photograph, but obviously you could scale it up and work out the size. And a really good old boy in Wales who makes radiators called Star Engineering. We sent him a photograph of the radiator and one thing and another, and he made us a shell, which we tried on the car and found it was the right, looked right. But later on, because I've got this book, and the funny part was, it tells you exactly what size radiator should be used for the hallscott. I can't see where it is just like that, but it was so many square inches, and when we measured up the hallscott radiator that we'd had made, from the pictures of the Peugeot, it was exactly the right size of what is said in the workshop manual, so that was another bit of luck we had.
If you make things too good, no one would ever buy new stuff, so it's out of business, wouldn't you? Yeah, and also the oil gallery tubes that feed the mains, they're soldered, the nuts are soldered to the actual olive bit. Yeah, blobs of solder there, so these nuts can't unwind. See there?
Mm.
Oh, it's totally over the top.
So we've done the valve guides and we've just generally looked at the engine, because there was nothing really wrong with the car except that it leaked oil badly and it had been together for a couple of years, and I thought it's time we just had a look at it all, because it's got white metal bearings and they're the original white metal bearings, and you know, they're always a little bit worried when they're that old, but we took it to bits and they're all absolutely lovely. And the only real problem we found with the engine is the valve guides were badly worn. Well, they were badly worn when we put it together, but they're even worse now. So we've sleeved the valve guides, as you see in the thing. But really looking at the clutch, and we've modified the clutch because it was a big old Mercedes van flywheel and clutch, and we put sintered linings on the original clutch plate. But when we really looked at them, they were only actually touching on one side. The other side hadn't got anywhere at all. So there's got to be a reason, and we looked and looked and looked, and we can't find any reason except that I reckon because the engine and the whole chassis and everything tends to twist and move, that the first motion shaft is seizing on the centre of the clutch, and it's stopping the clutch from revolving square. So when you let the clutch out, the first face touches, that's what does all the slipping, and then the other one just rests up against the flywheel. So we're now going to put the engine in with the first motion shaft in and see how well the engine lines up with the gearbox. Although there is a universal in the middle of it all, which comes from a Bentley, so it's Bentley design, which you'll probably see in the pictures. But anyway, that's our next job, is to line everything up and look how it works. And then I think when we made the first motion shaft, obviously a toolmaker made it and all the gears were cut on it and the splines were cut on it, and it's all too clever. It's too tight, it wants more clearance. Because I remember when I had a Morgan freewheeler, that just had a square in the middle of the cone clutch, and when you let the clutch out, there was enough drag on the square to stop the clutch going in. So you let the clutch out and then you lifted your foot off and the clutch would go into gear, and I think that's what's happening on the Hall & Scott. But other than that, lovely. We haven't found any real problems. So, and this is obviously part one. So the next part will probably be starting it up, although we've got a few ideas for that. Because I want to give the car more, it's got plenty of torque, but it doesn't want to run slowly, and I'm going to improve it running slowly. So that's something else that we're going to. But anyway, don't forget to subscribe, and good luck to everybody in the new year. And let's hope we can get away from this disaster movie, because it's getting boring after 2 years. Especially when you get to 80 years old, you ain't got a lot of years left. So anyway, good luck everybody.